Hello kids, here we are. We're going to be going through the Geometry June 2018 exam. This first part is going to be questions 1 through 12. So let's see down here. So the first question, if I can get things, it's going to be a little rusty on the beginning here, sorry. Okay, so after a counterclockwise rotation about point X, the scalene triangle ABC maps onto triangle RST as shown in the diagram below. Which statement must be true? Okay, so if that's what's happening, let me get my thing here. That means A is going to R. Oh, do I not have a pen? Oh, that it is. A is going to R. B is going to S, and then C is going to T. Which statement must be true? Is A congruent to R? A congruent to S? Well, no, it's not congruent to S. CB and TR, so CB would be not the same as TR. So it's got to be angle A is going to angle R. Easy peasy. They started it off with a baby question, right? Then you've got to do a little bit of math this time. So in diagram below, AB is parallel to DEF, AE and BD intersect at C. The measure of angle B is 43, CEF is 152. So my first reaction when I see a picture like this is just to start filling in some angles, because you can see down here there's all these choices. So right here I see a 152, which means that whatever's here should sum to 180. So 152 minus 180 is 28. It's got 28 degrees here, which is a linear pair. And then they told me that AB was parallel to DEF. So I can use alternate interior angles to say that this angle, 28, at A. Now I have a little baby triangle up here. So I have 28 and 43. Which means this angle here at ACB, we've got to add to 180 there. I hate how I drew that. Sorry, it was really bad. The angle right here in the center would be 109. And then we have vertical angles are congruent. So this angle is 109. And again, we have alternate interior angles. So this angle would be 43. So now all I really need to do is check out all of these different things. Angle D is 28. No. Angle A is 43. No. ACD, I don't have a 71, so I'm going to skip that for a second. BCE is 109. Well, BCE is this angle. And if those have to add to 180, then this is 71. Oh, there's a 71, so it must be this. ACD is 71 degrees. Yes, true, because these two are vertical angles. So it has to be choice 3. All right, so then number 3, in the diagram below, line M is parallel to line N. Figure 2 is the image of figure 1 after a reflection over line M. So this reflected over to here. Fabulous. Figure 3 is the image of figure 2 after reflection over this line, N. Okay, so what has happened? In a reflection, the size doesn't change, the orientation can change. So if you look at this, it says, which single transformation would carry figure 1 onto figure 3? Well, it's not a dilation because there's no change in size, okay? Well, figure 1 looks the same orientation as figure 3, so it's not going to be a reflection because it's not flipped. It's got to be a translation. So if I can, I just slide it, right? I can just go whoop and slide it over there, yeah? So that would be a translation. Number 4. Okay, so we again have basically the same diagram we saw just a second ago in the question number 3, or question number 2. So we have all of this information. AF and DB intersect at C. They don't say bisect. AD and FBE are drawn such that the measure of angle D is 65, CBE, this exterior angle, is 115, DC is 7.2, AC is 9.6, and FC is 21.6. Okay, so we're given all of these things. What is the length of CB? All right, they want to know this right here. The best advice I can give you about similar triangles is to draw them, okay? Redraw them in the same orientation off to the side. So, right now I'm going to redraw the little baby triangle, A, D, C. This is 7.2, 9.6, and 65. Okay. Now I'm going to redraw the big triangle, but in the same orientation to the best of my drawing abilities. Okay. Well, we know that C is congruent to C, right? So C is going to be here. And what else did they tell us? So we have to know that B matches with D. So B is going to go here. And F, wait, is it F? No, yeah, it's F. Hello. F matches with that. Okay. So C to F is 21.6. And then we're not given any other sides there, right? So this angle, the reason I know that is because this angle right here would be 65. Angle D and angle B are congruent, both 65. Yeah? All right, and then C is congruent to itself. Vertical angles are congruent. So right there. Okay, so that's how we can line them up. We want to know the length of C to B. So I'm going to call that X, which is your favorite thing to call things. And now I just have to set up a proportion. So I'm going to say, I made this easier for myself. I'm finding X, and that matches with 7.2 in the other triangle, is equal to 21.6 for my big triangle, which matches with 9.6 for my small triangle. You get to cross multiply here. So 9.6x is equal to 7.2 times 21.6. I'm going to need a calculator for that, don't you think? Where's my calculator? That's not it. Found it. So 7.2 times 21.6 is 155.52. I think this is where I am. Hello. Oh, what did I just say it was? I lost myself, sorry. 155.52. So then you have to divide by 9.6 to solve for x. And using the calculator, that will give you 16.2, which is choice 3. Okay. So given square RSTV, let me move this over a little bit here. Given square RSTV, where RS is 9, if the square is dilated by a scale factor of 3 about its given center, what is the perimeter in centimeters of the image after the dilation? So you have to know a couple of things here. First of all, a dilation means multiply, right? Multiply, multiply, multiply. So we're multiplying by a scale factor of 3. So first thing I'm going to do is I'm going to draw my little RSTV right here. There he is, RSTV. It's a square to the best of my drawing abilities. Each of these is 9, which means it has a perimeter of 9 times 4, which is what, 36? Whoops. So if we dilate this, each of the sides is going to be multiplied by 3. So my big picture, 9 times 3 is what, 27? And so the perimeter, let's just add up the sides. The perimeter is 108. P, not area, P. P is equal to 108. So the fact that you're supposed to know is that if you dilate an object, the perimeter will also be dilated by that same scale factor, but the area is dilated by the square of that factor. So that's the factor you're supposed to know in that question. All right, so in right triangle ABC, hypotenuse AB has a length of 26, side BC is 17.6. What is the measure of angle B to the nearest degree? So if you didn't draw a triangle, you're doing it wrong. So a right triangle to the best of your abilities. So let's see, hypotenuse is AB, so that means the right angle's at C. The length of 26 centimeters. BC is 17.6 centimeters. We're finding the measure of angle B to the nearest degree. So we have, in relation to angle B, we have the hypotenuse and the adjacent side. So I'm sure that many of you write this on your paper. Soka, Towa, or some old horse caught another horse taking oats away, or something about a hippie that I will not say. But as soon as I write A and H there, I know that I'm using this little side ratio. So cosine of angle B is equal to the adjacent side over the hypotenuse. So in order to solve for angle B, we do cosine inverse. Cosine inverse. So this is definitely a calculator question. Now, your calculator, it's asking for this in degrees, so your calculator has to be set up in degrees, and depending on, whoever your teacher is or maybe how you're setting things up all year long, you just want to double check that that says degree there. So cosine inverse is right about here, and I'm going to get a fraction, make my life a little bit easier. 17.6 over, 26? Is 47.39. So 47.39, does that round up to 48, or does that stay at 47? Okay, it stays at 47. I hope you didn't fall for that. All right. Oh, number 7. Number 7 requires a calculator too. So we got to be smart here. You should really label your pictures. Be smart about what you're doing, okay? Don't think like, oh, I'll be fine. Stop doing that. Draw the picture. I'm working on my coffee. Unlike Krause, I love the Starbucks. I love it so. The nitro brew is fabulous. It's so good. Okay, sorry. Trying to wake up here. It's Sunday. I should be sleeping. All right, so we want to find the volume of this thing. So we're finding the volume, and there's two things going on. You have a rectangular prism here, which is great. Easy peasy, rectangular prism. It is really hard to draw with this pen, by the way. So the volume of the rectangular prism is length times width times height. And I'm just going to assure, let's double check all of our units. Feet, 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 right? So I'm going to have 12 times 20 times 45 is going to be the volume of that rectangular prism. And I don't even have it written down, so I guess I'm going to do that in a few minutes. Then this part here, and I thought this was a little bit mean, so that is part of a cylinder, but it's half of a cylinder. So the volume of the half of a cylinder is 1/2 pi r squared times the height, right? Now, the thing is that typically when we see a cylinder, we are calling the height this length, right? And in this picture, it's tipped over on its side. So what we have, our height is going to be 45, and we actually need the radius. So the diameter is 20, but the radius is 10. That literally happens in almost every geometry question. They will, I would say 9 times out of 10, they give you the diameter to see if you're paying attention, and you have to find the radius. Don't fall for it. It's a dumb thing to fall for, okay? You're smarter than that. So our radius is 10. So this is equal to 1/2 pi radius of 10 times the height, which is 45. And we know we're going to add these up. So here's the thing. I am a big fan of just putting the whole stupid thing in your calculator all at once. So we have 12 times 20 times 45. And then we have 1/2. You could use 0.5 if you wanted. I'm not mad if you do that. Times pi times, I'm just going to write 100 because I know 10 squared is 100, times the height, which is 45. Oh, I forgot his calculator is stupid, by the way. So then I'm going to say, okay, I want to do this plus this, and I have to put a decimal point here because his calculator is special, just like Mr. Krause. Okay, so 17,868.583. Let's go back here. 17,000, oh, where am I? 17,868.583. So, oh, that's an easy one. I thought it was going to be close. It's not. It's right here, near his foot. Not bad. The only trick there was the height was 45, and you had to think about how the picture was drawn. All right. Oh, I got to scoot this over again. Hello. Oh, dang it. Anyways. Oh, my favorite. Oh, look how cute this is. I miss all the trig I used to teach. So in a right triangle, the acute angles have the relationship that the sine of the angle is equal to the cosine of this angle. What's true about the angles? Well, you have to know that in a right triangle, my right side up here? In a right triangle, whoop, 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 yeah? These two angles will sum to 90, right? So the sine of this angle is equal to the cosine of this angle if these two angles add to 90. So the insides here add to 90. So 2x plus 4 plus 46 is equal to 90. So 2x plus 50 is equal to 90. 2x is equal to 40. X is equal to 20. Now, that was easy and fabulous. Okay, we love that. That's a fun fact. That's something that you need to memorize. So whether you have to put it on a flashcard or do repeated practice questions with it, that's a really common fun fact that they like to test you on. Oh gosh, this question. You know, of all the things, you had to give us this picture. So we got a lot of things going on here, and you just got to be careful. So AB is parallel to DFC. So AB parallel to DFC. Okay, fine, which means quite a few things about angles. So, you know, this is a transversal, so this angle at B is equal, well, I guess, yeah, well, that would be this whole angle here. So maybe we shouldn't do that one. I can erase that. I should say that this angle at B is equal to this angle at F. So we've got a lot of alternate interiors going on here, and then we've got vertical angles, so this angle would also be the same, right? Let's see, the angle C is the same as angle A because they are parallel there. Got a lot of things going on. C, okay, let's go back up here. EDA is parallel to CBG. Fine. EFB, and AG are drawn. Fine. Which statement is always true? So now you basically have to go through these things. Here's the thing that was kind of obvious to me. We haven't been given any sides. Not a single side. So when I see this, and I don't have any sides in this question, there's nothing about congruent sides or anything like that, I'm probably going to stick over here with the similarity since we have just a bunch of angles, if that makes sense. There's nothing about bisecting any sides or anything like that. So I'm going to go with similarity as my gut here. So BAG. You know, I'm going to get a highlighter. BAG. Whoa. Sorry. Is that similar to, what question? AEB. AEB. Okay. Or, okay, so let's see if we got that going on. Let me get my pen here. Okay. Oof. Okay, so let's see here. Well, that would mean, if we look at this way, that this angle at A, call it 1, is congruent to this angle at B, which is 2. So we have one angle congruent. And this angle at B is not going to be the same. Where am I? Oh, here we go. Because it's not made with the horizontal here. So that's not the same. We have no information about these two. So we've got nothing. We can't do angle similarity there. So I'm going to erase my highlighted shenanigans because that's a lot of shenanigans there. Holy smokes. Okay. Now it says DEF. DEF is this little guy. Is that similar to AEB? AEB. Okay. Does that seem likely? Yeah. So you've seen that picture 1,000,007 times. So right now we know we've got parallel sides. And we know that this side is parallel to this side. So this is a mid-segment. So we can say, all right, well, this angle at A, angle 1 from before, is congruent to this angle at D. And we know that this angle at F is congruent to this angle at B. We have angle similarity. So it's got to be choice 4. Oof, that picture is just a pain. All right, so the base of a pyramid is a rectangle with a width of 4.6 centimeters and a length of 9 centimeters. What is the height in centimeters of the pyramid if its volume is 82.8 centimeters cubed? Okay, check your units. Centimeters, centimeters, centimeters cubed. I feel pretty confident. Now, you've got to go to your formula sheet, and I'm hoping it's in here. Okay, I'm going to go as fast as I can to the formula sheet. Volume of a pyramid. Sorry that it's going to take me 40 minutes to get to the volume or the formula sheet. Sorry. Oh, did he not even include it? No, maybe he did. Nope, he didn't even include it. Okay, so on your formula sheet in the back of your test that I'm sure you tore out like a good little minion. Uh-oh. I might have just done something stupid. Okay, sorry, so I broke it for a minute. Found it. Okay, I also found the formula sheet, so Krause to the rescue, I guess. All right, so June 2015, formula sheet. Okay, it's always the same formula sheet. We are looking for the volume of a pyramid. Oh, goodness gracious. Down here, it says 1/3 base times height, and B stands for area of the base. So in this pyramid, they're telling us that the pyramid has a base that is a rectangle. So I always try to the best of my abilities to draw kind of a picture. It's not very good. So it says with a width of 4.6 and a length of 9, and we're working in centimeters, we established that. And then it would look something like this. Yeah. Mock my drawing abilities. I don't care. But then we would need to know whatever the height is, and the height is always makes a right angle. So the volume of this pyramid would be 1/3. The area of the base is just length times width times the height. So the volume equals 1/3. We have a length of 9, a width of 4.6, and it says what is the height? And on this side, I should have the actual volume, which is 82.8. Okay. A couple of ways you can do this, and I'm going to guess because you are not Algebra 2 students, what you probably would do is put this in your calculator and get a number and have the h here, right? So let's go do that. Let's clear that out. Okay. So 1/3 times 9 times 4.6. Okay. Is that right? I don't know if that's right. Oh no, we're okay. So that is 13.8, and it feels weird because it's rational, yeah. So 13.8. So now I just have to divide by 13.8 to get h by itself. So h is going to be equal to, so 82.8 divided by, so we have a height of 6. Now, the other way you could have done that, and I want to make sure I say this because I feel like it's important, is you could have done guess and check here. You could have plugged in the choices to see which one worked to get you that volume. That would be the same thing, and you could do that all in the calculator. So you should probably do this question maybe 2 ways, like solving it and then going back and just making sure it works out. That's one of the best things about the questions that you can check and use the calculator for, because there's very few in geometry. All right, so then we have, let me click this. Sorry, I'm trying to move this over. In the diagram, we have a right triangle AED. Okay, that's big right triangle. BC parallel to DE. So this is, again, one of those mid-segment things, right? You feel like they just keep haunting you? Yeah, you should probably know how to do it then. Which statement is always true? All right, so again, this is one of those situations where redrawing the triangles is probably your best move. I know it seems kind of silly, but it will help you. So I'm going to draw the baby right triangle that is ACB. And I'm going to say that B is here, and we'll put two little things there, okay? And then the big triangle, A matches with A, E is the right angle, matches with C, and then D matches with B. So this angle matches with this angle. Okay, so we know that those are similar triangles. Which statement is always true? Does AC over BC, okay, what would have to match with what? That AC would match with AE. Is that what's on top on the other side? No, they have it flipped. So no. All right, AB, so the hypotenuse here, matches with AD, true. But now we have to go back to the small triangle. BC, DE. Does that one work? Yeah, that one works. So it's choice 2. You would have to go through your other choices like that. And just for fun, real quick, AC, CE, no, that's not even a thing. Okay, no. DE, which is this bottom side, matches with BC, true. But then DB, no, doesn't work out, not that one. So it's definitely 2. All right. Scroll down to 12. Okay, so an equation of a line that passes through the point 6,8 is perpendicular to a line with the equation y equals this. Ladies and gentlemen, if you don't know that perpendicular lines have negative reciprocal slopes, we're in big trouble. So look at that slope. Write down the negative reciprocal slope would be negative 2/3. So I'm looking at these and I go, oh, it's not 1, that would be possibly a parallel. It's not 3, that would be parallel. Okay, so it's possibly these two, right? Well, it has to pass through the point 6,8. which means if you plug in 6 and 8 for x and y, let's make sure we do x and y, then the statement will be true. So if I plug in 8 for y here and 6 for x here, that's 0 equals negative 2/3 times 0 is 0. That's true. So that's going to be my answer. Just check this out. If I plug 8 here, 6 here, I get 16 equals negative 2/3 times 12. No matter what, a positive is not going to be equal to a negative. It cannot be that answer. It has to be choice 2.